Hey folks, just checking if everything is all right. Just give me a second. I'll just check if the microphone and everything else is all right. Just give me a second. Hey folks, yeah, so I can hear myself, and hence the microphone must be decently okay. So yeah, so let's get started. Today we have a bunch of questions, and let's solve them one by one. And I'll keep an eye on the live session, live chat also. Actually, today is a holiday in Andhra Pradesh and Telangana. It's the Telugu New Year called Ugadi. That's why it's time off for most of our employees. So I'm doing this live from home. So I might miss out a few of your comments, but if some of my teammates are joining in, they would answer as many as possible. But unlike the regular live session where all of us sit together and do it, where there is immediate response for your questions, it might be slightly delayed today because I'm doing it solo. Okay, I'll keep an eye on all the comments that are coming in. I'm just holding on to my phone just to ensure that I don't miss anything. Uh, Sounds good. Yeah. So let's wait for a few minutes. Again, I'm just checking the comments here on the phone, just to see that if there is anything that I'm missing, I can just answer it here. Okay. So let's look at the chat window. Good. Okay. Happy to hear that you like some of the lectures, Saket. Very good. So let's get going. Hey folks, thank you for joining in on a Saturday evening. And yeah, so yeah, any questions you have that I could clarify as we wait for others to join in for a couple of minutes? Just shoot them in the chat window. I'll try to answer as many as possible. Yeah, Ayush, that's a very valid. We are fixing that bug right now for some of the links that we have given, some of the code links that we have given. They're not copyable. We're just fixing that bug. Our team is working on that. We'll just fix that soon. Okay, just give us a couple of days. This is something that we are fixing with top priority. It's a small bug wherein we disable the Control C, Control V, and basically all control keys we have disabled for some specific privacy related issues, and we will enable at least Control C, Control V, or we'll find a solution for that. Okay, sounds good. So somebody's asking a question about pointers. I'll surely cover this when the turn for pointers comes, because we have not yet covered pointers. I think it is fair to cover it when the turn comes. So will you start any batch in May around May 28th, right? So this is April. Yeah, I'm sure we'll have a batch that is starting in late May also. I'm very sure we'll have a batch sometime in late May for sure, because that's the summer vacation time. We'll have more batches starting in during May. So Ayush is asking about okay, any desktop app improvements or website improvements that you want, just shoot us an email. We'll add it to a list of topics and we'll try to fix each of these. And I think Ayush, the question you're asking about quality, I think we cannot control it because we use third-party providers to stream our video. Because hosting video and streaming it ourselves is a very operations heavy thing. So we'll see if we can fix it in code using the APIs that some of these. Please send us all of this because we'll lose it otherwise. So any suggestion that you have on how we can improve the desktop app or the website, just shoot us an email. We'll keep it in a list, and our web development team and our desktop development team will start working on them one by one based on priority. Okay. Hey, thank you, folks. Happy Ugadi or Ugadi Subhakankshalu. Okay. Sounds good. So let's get started. Hey, folks, all the desktop or mobile issues, please, or the issues with the website, please shoot them because it's hard for me to make a note of everything and pass it on to our software development team. Just shoot us an email. We'll have somebody take a look at all of these and fix as many as possible as soon as possible. Okay. Yeah, I'm happy, Sunit, that you liked some of the questions for practice problems. We focus a lot on the practice problems because we think, as I keep repeating myself many times, practice is the key. Frankly speaking, you might know all the theory under the sun, but if you don't practice for gate, you'll not get a gate rank. It's as simple as that. That's why we put in so much effort in setting up the practice problems and also doing this practice problem solutions live, right? So that's the whole reason why we focus so much on practice, which is at the core of your ability and bringing you up to the level where you can crack gate questions. Okay, I'll turn off the camera and I'll move to my desktop sharing so that we can get started with. Okay, so that we can get started with these questions. Okay, so just a second, give me a second. Yeah, so I have a bunch of questions here. I think some of these questions have been modified because we have a bunch of questions for C. 2-3 of them you may not find in your test. This is an older test that we set up. So if you see a couple of questions that you don't see in your test, it's okay. Don't worry about them. We'll revisit those questions in one of the future tests. Okay, I think there was a small confusion when we were setting up this practice problems. A couple of them here and there got mixed up. Okay, so let's go problem by problem. Okay, again, I'll keep my smartphone on so that I can look at your comments in case there is anything. Okay, so let's get started with the questions, right? So the first question here is, what is the output of this program? Again, you're given, you're including stdio, main, you have this bunch of variables. So let's actually work it out, right? So if we start to work out this problem, we will have I equals to 0. So let's look at this. It says m is equal to I plus plus, right? M equals to I plus plus. And then, yeah, so m equals to I plus plus, logical or j plus plus. Just give me a second. I'm just adjusting my computer so that we can better, so that I have more clarity when I'm answering these questions. Just give me a sec. Just give me a sec, folks. Just adjusting it here. Okay. So I plus plus, I hope I'm audible. I hope my audio level hasn't dropped. Okay. So I have, okay. So let's go one by one. So I have m equals to I plus plus, logical or, sorry, or your basically or j plus plus or k plus plus. Now let's see how the whole thing works out here, right? So if you notice, right? So you have I equals to 0, which means I will first be used here and then incremented, right? So I will first be used. This is your postfix increment, right? So I will first be used here. So it will be 0. And after I is used here, it will become 1, right? Or j plus plus. When you have j plus plus, what happens now? So j equals to 1, right? So this is false. 0 basically means false, right? Now you have again a logical or and a logical or, right? So you have j plus plus. When you have j plus plus, j equals to 1. So it will give 1 and then j will be incremented, right? So first 1 will be used here. Now if you notice, if I have 0 or 1 or anything else, what is the total value? Because I have seen a non-zero value which is true, or whatever this value is, the total expression will evaluate to true. So as we discussed, logical or, we discussed this in one of the videos, right? If I have two expressions with a logical or, if this evaluates to true, this will not even be evaluated. This expression will not even be evaluated because true or anything else is going to be true, right? So this is false, hence this will be evaluated, right? Since this is false, this will be evaluated because there is left to right associativity for logical or, right? So this is false, so this will be evaluated. The moment this is true, this need not be evaluated altogether. So k would not get incremented here, right? So what are you trying to print? You're trying to print mij, right? So false, true, whatever it is, m is going to be true, right? M is going to be true here. So m is going to be 1. I got postfix increment. I was initially 0. We used I equals to 0 here, but it got a postfix increment, which means I is going to be equal to 1. What about j? J was initially 1. Look at this. J was initially 1. I incremented it. This is a postfix increment. So j would become 2 now. But k plus plus was not even executed. This is the important aspect here. K plus plus was not even executed, right? Because this already became true. True or anything else here, any expression that you have here will not be evaluated because of this rule that we discussed in the course videos, right? So k would not get incremented. So k would remain to be 2, right? So the right answer here is option B. This is a very tricky option. Okay, so a lot of people make this mistake wherein they mess up and increment k also. But if you think about the logical part, if you think about logically, because this first statement became true or first expression became true, the second expression would not even get evaluated at all. That's why your k plus plus never gets evaluated in the first place. That expression does not even get executed or evaluated, right? So your final output would be 1, 1, 2, 2. Okay, this is a tricky case. Again, let me tell you one thing. Okay, these types of tricky questions. So this is from my own personal and professional experience. These types of tricky questions are very good in competitive exams and multiple choice questions. They're very good because they help the whoever is setting up this test. They help you test how well you understand the internals of C. But when you write code in the real world, okay, if you're an actual software engineer writing code, please don't write your code like this. Please don't write your code. I strongly recommend you don't write your code like this, because somebody who is not an expert in C, because remember, code also needs lot of readability. Your code, remember, the code that you write it should be readable. Others should be able to read it and understand it very easily. If you write very complex expressions where people have to know precedence of operators, where people have to know associativity of operators, people have to know all these boundary cases about logical or, most people may not know, or people may have forgotten it, right? So in such a case, writing such tricky code, while it is fun for multiple choice questions and as brain teasers, when you actually write real code, please don't do this. Okay, because if you write this code, I come back and I read this, imagine if it's been like few years that I've written code in C. If I come back to this code, I'll be lost and I'll most likely make an error. Okay, so if you ever become a software engineer, or if you're already a software engineer, please write much more readable code. Nobody gives you extra points for writing tricky code. Okay, actually, if I were your manager, I would say, please stop writing tricky code and write sensible and readable code. Okay, this is all good for competitive exams, for multiple choice questions, etc. But in the real world, please avoid it. Okay, so this is again very, very important. Okay, so the answer is 1122. Okay, so this is good. So let's go to the next question. Okay, so the second question here is this. Okay, again, the order of questions that you have may be different from mine because we randomize this order sometimes. Okay, so let's go to this question. What does it say? Int a and b, a equals to 3 comma 1. This is very good. So let's look at this statement. A equals to 3 comma 1, right? So now if you remember, this is assignment and this is comma. See, this is assignment operation and this is comma operation. Assignment operation has a higher precedence than comma operator. So first the assignment operation will be executed. So what would this result in? This will result in a having a value of 3. So this will result in a equals to 3, right? Because first this assignment operator will be executed. So a will become equal to 3, right? And then the comma operator will be executed, and there is no value in this comma operator here. It would not change anything in a. But what about this line now? So b equals to 5 comma 4. This is a tricky case because we have the comma operator inside parentheses. Remember, this is parenthesis. Parenthesis has the highest precedence. So parenthesis will be executed first. So when you execute 5 comma 4, what would this return? There are two integers here. The operator here is comma. The operator is not a plus or a subtraction or anything. So this, because it's in a parenthesis, this will be executed first. When you execute 5 comma 4, this will result in just 4, because it will execute 5. There is nothing to be returned. Then it will execute 4. 4 is just a constant here. So this will return 4. When that is returned, then you have the assignment operator here. So what would it become? It becomes b equals to 4. Right now, what are you trying to print? You're trying to print a plus b. When you print a plus b, it will be equal to 7. Right? So this is a tricky question where you have to understand about the precedence of operators. The whole objective here is to test your precedence of operators. That's all there is. Okay, fairly straightforward question. The key thing that you have to know here is when you have an expression like this, the key thing you have to remember is when you have an expression like this, with 5 comma 4, it would return this value, which is 4. Okay, this is the key thing that you have to know. Again, for all of these, you can actually use IDE 1 or online GDB. Okay, and actually you can write this code on these platforms and test it. Okay, so that you can double check. Again, all these platforms use GCC. I think a very recent version, and they all are pretty reliable. Okay, sounds good. So the third question. So if we go to the third question, this is a tricky question actually. Actually, this question is slightly hard because here there are some additional concepts of functions. Right here, there are additional concepts of functions that I have not yet discussed. So I think this question got changed when we updated the questions. But anyway, let's solve this. Okay. So the key thing that you have to remember is how hash define works. Again, we'll discuss about hash define in lots of detail later in the course. But let me explain you anyway. Since we're on this question, let me explain you. So what hash define does is literally wherever it sees square x, it will literally wherever it sees this, it will paste this. It literally paste this. Okay, let me explain you how it works. You have x, y equals to 1. Now it sees square y plus 1, right? So the moment it sees square y plus 1, that's what it sees, right? It will replace this statement as this. It will replace square y plus 1 as y plus 1 multiplied by y plus 1. That's what it will replace as, because when you have square x here, what did it get replaced with? X star x, right? So wherever you have square x, it got replaced with x star x. Similarly, whatever you have inside this, see what did it do? Whatever is there in this simple braces, it took that and it literally returned x star x. So hash define literally pastes this here in the code. Okay. So again, you'll understand this better when we learn about functions and hash define in a lot more detail. But now x will become equal to this. Now, if you look at this, what is y? Y equals to 1. So this becomes 1 plus 1 star 1 plus 1. So what will this be? 1 plus 1 plus 1, which is equal to 3. Because multiplication has a higher precedence than addition, right? So when you print x, it will actually be 3. It will not be 4. Okay. So for you, for this, to answer this question, the key aspect that you have to know about is whatever you put in hash define, especially when you define a function using hash define, right? When you define a function using hash define, again, we'll learn this later. Don't worry about it. If you don't know what a function is, or if you're not comfortable with functions, that's okay. We'll revisit this topic later. Okay, I'll revisit this question again in one of the future sessions. Okay, so literally what you have to remember is, even if I have something like this, even if I have hash define pi 3.1415, wherever it encounters pi, it will simply copy this string or this constant there. Okay, that's how it works. Okay, I hope this is clear. Okay, so just give me a second. Okay, yeah, most of you are answering the questions. Okay, so yeah, I'm glad to see that some of you are answering the questions here. Yeah, Saket, you were saying that some of these questions are not in the exam. I think 2-3 questions got swapped out and slightly different questions got put in. But I started taking the test when I set up this. I think I had the older questions in. That's okay. We'll cover some of them. If there is any question in the test that you have, there may be 1 or 2 new questions that I'm not covering here. If you do not understand the answer, please do revert back to us. Okay. So there is a small mess up with a couple of questions. So that's okay. I think my team removed this because when they evaluated this question the second time, they realized that this requires us to understand functions. There may be a couple of such questions. Please excuse us for that. We'll avoid that mess from next time onwards. For now, let's just continue with this. Okay. Since I've already started the test. Okay. Sounds good. So the 4th question, right? So if I go to the 4th question, this is actually a very interesting question. It says printf %d. All this is all right. 1 left shift 2 plus 3 left shift 4. Right? Remember the mnemonic or the memory trick. You have Puma's rebel tack. Puma's rebel tack, right? So if you remember Puma's rebel tack, this is your shift operators, right? Your shift operators is here. Your S stands for shift operators. Your addition operation is here. So your addition operators has higher precedence over shift. So first this addition will happen. So 1 left shift 5 left shift 4. Okay, and left shift, because if you remember, only A, U, T, only these 3 have right to left associativity. Everything else has left to right associativity. So first we'll run 1 left shift 5, then left shift 4, and that's actually very straightforward. So what is 1? If you write 1, right? And since this is an integer constant, I'm assuming integers are represented using 2 bytes. So this is the first byte. So this is the second byte here, right? This is the second byte, right? So this is 1, right? Because this is 2 power 0 in the binary representation. So I'm shifting it by 5 first. So 1, 2, 3, 4, 5, right? So it will shift here. 1 followed by 1, 2, 3, 4, 5. Rest everything will again be zeros. Okay, so since I've shifted 1 by 5 bits, so 1 was here, I shifted it by 5 bits. So I left shifted it by 5 bits. So I'll get 5 zeros on the right. 1, 2, 3, 4, 5. Rest everything will be zeros. Now this, so this is the result that I got now. So this result is this. Now on top of that result now, I left shift it again by 4, which means I'll shift 1 again by 4 places, right? So what will happen now? I'll have 1, I'll have 4 zeros, and then 5 zeros. Okay, so this is 2 power 0, 2 power 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 2 power 9 into 1. Rest everything else is zeros and zeros. So what is 2 power 9? 2 power 9 is 512. As a computer science engineer, you have to remember the 2 powers because that's what we use extensively. 2 power 8 is 256, 2 power 9 is 512, 2 power 10 is 1024. Anyway, you'll remember it by heart as time progresses. Okay, so 2 power 9 is 512, and that's what I have. So look at this. I'm taking this whole thing and I'm printing it as an integer, right? So the answer here is 512. It's a fill in the blank type answer. Okay, very simple. So let's go to question 5. Okay, so question 5 works as follows. Okay, let's go to this question 5. Okay, I have int a, b equals to 5, right? I have a equals to 0, logical and minus b, right? This is my assignment operator. This is my logical and. This is my unary operator. Again, this is prefix. But if you notice this logical operator, what will happen here? Okay, if you notice what will happen here, this is already false, right? This is already false, right? B is 5. Remember, B is 5 here, and A is, so we'll have to assign. This is false. Since this is false, the whole logical AND part that you have here, because this is logical AND, false and anything else is false, right? So this whole thing would not even get executed in the first place. This whole thing would not even get executed because I already have false here, right? So when you print this, what will happen? It will print a equals to 0 because false and anything else is false, and false is nothing but 0. So a would finally get a value of 0, and b, the minus b would not get executed to start with, right? Because as we have seen, right, if you have something logical and some other expression, if this is false, this expression won't even get executed. We discussed this, right? Similarly for logical OR, if this expression is true, this would not get executed because there is no need of it being executed, right? So a will be equal to 0 and b will be equal to 5. So b is the right option here. Okay, I hope this is clear. Okay, so now let's go to question 6. Okay, so let's go to question 6 now. Okay, this is actually a very interesting question. I really liked because this was a tricky question when I was trying to solve all of these questions myself. So I have I equals to 5, j equals to 10, k equals to 15, right? It says printf size of, look at this. It says printf size of, I have k, which is 10, divided by equal to I is 5, plus j. This is what I have. Okay, and it says what is the value of k. Now, one thing, a very important property of size of operator that I did not discuss in the course videos is this. Okay, whatever expression you have here will not be evaluated. This expression will not be evaluated inside the size of operator. Okay, but it knows that because I, j, and k are all integers, any mathematical operation, all of these operators of division, right, or division equal to, sorry, k equals to, not 10, sorry. This is, sorry, k equals to, k by equals to 5 plus 10. I'm sorry, this is not 10. K by equals to, because this is an assignment operation, right? So whatever I have here, all of them are integers. So the size of operator will not even evaluate this expression. It will say all of these are integers. So all that we care about is size of integer, right? And if the size of the integer on your computer is 4, right? So it will actually print 4. So this line will actually print 4. And k would not get changed. Look at this. The second thing that I'm printing is printf k, right? When I'm printing k, this whole expression did not even get executed in the first place because whatever expression you have here, size of would not execute this. This is a very interesting boundary case. Again, this is part of the C99 definition. Again, there are multiple standardizations of C, ANSI C being one of them, right? There is an updated version called C99. in which some of these boundary cases have been much more clearly defined. So if you look at the huge documentation for C99, it clearly states that whatever expression is there in size of would not get evaluated. And most compilers, most C compilers today will stick to the C99 definition of C, or the rules that are part of C99. Okay, this is a rule that I did not cover explicitly, right? So when I printf k, it will be 15. So what would it print? It would print option B, 4 and 15, right? So because there is a space here, 4 space, again 15. So option B is the right option. The key lesson here is that whatever is there inside size of would not get evaluated. Okay, that's a key aspect. So now let's go to question 7. Okay, let me just look at the comment section. Just give me a sec. Just give me a sec. Okay, all of you are answering questions. That's very good. Very good. I'm happy that you're answering questions. Okay, sounds good. So let's go to question 7, right? Again, folks, since I'm the only person looking at comments today, or the live chat, if there is anything that I missed out today in the live chat, we'll try and answer that in the live chat itself. If we miss answering that in the live chat, just shoot us an email and we'll send you a response, right? Because as I told you, I'm not working from office today because it's a holiday for us. I'm just sitting at home and answering them. So I might miss some of the questions that you have asked in the live session. If any question is missed out, please email us. Okay, just please email us and we'll get you the answer. We'll respond back. Any confusion with any code here or anything that you think is not appropriate, shoot us an email and we'll respond back. Okay, sounds good. So let's go to question 7 here. So the question 7 says, okay, a equals to 6, a minus, sorry. It says a minus equal to, so let's write this down, a minus equal to, so this is a minus minus, this is in parenthesis. So let's evaluate this first. So a minus minus, right? So if you have a minus minus, so a equals to 6. So 6 will be used here and then a will become 5, right? Because this is a post decrement, right? So first a will be used here and then it will be decremented, minus, right? So you have minus minus a. This is again pre-decrement. So a is now 5, right? A is now 5. Now when I pre-decrement it, it will become 4, right? So this will become 4. So now it will become a minus equal to 2, right? Now what is the value of a right now? A's value is now 4 because of this post decrement, right? So a minus equal to 2, which means a equals to 4 minus 2, which is equal to 2. So when I print this, it will become 2. Okay, I hope this logic, this series of steps, I hope is clear. Okay, I hope this sequence of steps is clear here. Okay, again, this is a straightforward thing. If you know about post decrement and pre decrement, and if you're careful with that, you'll get answers. Okay, sounds good. So let's go to question 8 now. So here, just please ignore static. We'll discuss, I'll tell you one property of what static does. Also, please ignore arrays. We haven't covered that yet, but I'll anyway go ahead and answer this question since it's anyway there with us right now. Okay, so it's creating an array of, so for those of you who don't know arrays or who do not understand about static, it's okay. I'll tell you a couple of properties that we can use and answer this question. We'll discuss about static and arrays in like full length, in full detail later in the course, right? As we progress through the course. Okay, so let's go here and understand this. So whenever you have, so here it's creating an array A, which can hold 10 integers, and all of them will be initialized to 0 because I'm stating it to be static, right? So I'm creating an array A where everything will be 0, right? So where everything will be 0. And I'll have this index as 0, index 1, index 2, index 3, so on and so forth, index 9. Okay, now this is how C indexing works, right? Again, different languages have different indexing of arrays. Okay, so again, for those of you who don't understand this, please don't worry, we'll come back to this. Int I equals to 0, very good. Now it says AI, equals to plus plus I, right? So it says AI equals to plus plus I. Now look at this, I equals to 0, because this is pre-increment, I will become 1, right? So I became 1. So now what is the statement here? A1 equals to 1, right? So what happens here? A1 becomes 1. So when I print A0, A1 and A2, A0 will be 0, A1 will be 1, A2 will be 0. So option C is the right option here, right? Yeah, option C is the right option here. That's true. Yeah, I think yeah, option C is the right option here. Yes, right? So this is, again, this is very simple. For this, you have to understand, you have to know this properties of static, how arrays work. And if you don't know, it's okay. We'll come back to questions like these later on. Okay. So this is one question from a slightly advanced topic, which you have not yet covered. So the next question is this. Again, for all of you, typically in GATE, typically if you look at GATE previous questions, the very few questions that are asked which do not, so the reason we haven't had a lot of solved problems till now, right? We have had only, I think, a couple of solved problems till now in the course contents. That's because a lot of questions in GATE assume that you know loops. So they use a lot of loops, they use a lot of functions, they use a lot of pointers, right? They use a lot of arrays, all these concepts, right? So right now, since we have not yet arrived at these concepts, that's why we are not solving all the problems. But as we progress through the course, for example, after we learn about if-else conditions, switch, all the while loop, for loop, do while loop, etc., we'll have more solved problems where we'll use order precedence concepts also, right? I hope that is clear. Okay. So the reason we don't have many solved problems right now is because GATE does not just ask questions about order precedence. It combines those concepts with loops, functions, pointers, arrays, etc. Okay, so let's go to this question now. It says const. Okay, so it says const int a equals to 10, which means a is a constant. Now I'm trying to increment it. That gives a compile time error. So when the code is trying to compile, because a is a constant here, you can't increment it, right? So this will result in a compile time error. So the option D is the right option here. Okay, I hope that is, again, it's very straightforward. We have also discussed this in the course videos. So now let's go to question 10. What will be the output of the following code? Okay, so okay, again, this is something that I've not discussed in detail because I thought I'll discuss that when we learn about functions and return types. So one thing you have to remember here is printf. Suppose if I'm printing this, okay, printf as a function. Those of you who know functions, that's perfectly all right. If you don't know functions, anyway, we'll discuss about functions in a lot of detail. So printf is also a function which is present in stdio.h, or I shouldn't say present in, whose functioning is defined, or some of the details about how printf should work are defined in stdio.h. Okay, again, when we learn about header files, we'll learn what is exactly present in the header file. We'll actually see some of these header files in C. Okay, so for now, just remember that printf, how printf should work is explained in stdio.h partially, not fully again. Okay, again, there are a lot of clauses that I'm putting here, but don't worry about it. But printf at the end of the day is a function, and printf returns the number of characters. Printf returns the number of characters printed, right? So this is the return type of a print. If you recall, we wrote this program, right? Is prime. If you recall, we wrote this program called is prime in the introductory videos where we had a return type int, right? We wrote a function like this, right? Again, we took an input a, we did all of that, right? Here I talked about return types briefly there, right? If you have understood this, very nice. If you have not understood it in the course videos, that's also okay. Okay, we will visit about return types, all the details, pass by reference, pass by value. We'll discuss all of that in lots of details when we learn functions. But the key lesson here is when you print this, what happens? Printf applied course. So it will print applied course first. Then what are you asking it to print? What does printf return? Printf returns the number of characters that it has printed. So here it will print 13 because there are 13 characters here that it has printed, right? So again, you're saying printf %d and 13 is here. Okay, 13 is a constant here, which will be used as part of your %d. So finally, this program will print applied course 1, 3. Okay, so this is a very interesting property of printf. Again, we'll discuss this when we visit functions. Okay, I'm right now, I do not have a lot of leeway to discuss many of these things. Again, this is a question that we'll skip today. This question is not there in the test that you guys are seeing today. That's perfectly okay, because this function requires you to understand about functions, requires you to understand about for loops, etc. So let's just skip this. We'll add this question back in one of the future live sessions. Okay, so let's go to question 12 now. This is an interesting question. Okay, so let's go and check out this question. It says x equals to 10, a equals to 1, b equals to 2, c equals to 3, d equals to 4. It says x plus equal to a equal to b star c plus d minus a. Okay, again, let's write down our mnemonic. Puma's rebel tack. Okay, so this is tricky because there are so many operations here, right? So what is the first thing? If you look at this, this is assignment. This is assignment. Assignments are there in the later parts. Okay, here you have multiplication and addition. So first this whole expression would get evaluated first. Okay, with multiplication having higher precedence over addition and subtraction. So what is your B? Your B is 2 star 3 plus 4 minus 1. Right, that's what it would get evaluated to, right? This is 6 plus 4 10 minus 1 9, right? So this whole expression gets evaluated to 9. Now what do I have? I have x plus c equal to a equals to 9. This is what I have. Now this is an assignment operation. Look at this. I have an assignment operation here, and I have also an assignment operation here. Now if you recall associativity, you have AUT, right, in associativity. So A, which is your assignment operators, have right to left associativity. This is a very important part, which means first this will be, so first we executed this, then we'll execute A equals to 9, right? So A is now given a value of 9. And when you have A equals to 9, this expression will result in 9. We discussed this also, right? We discussed this in the course videos. If you have an expression like this with A equals to 9, this expression will result 9. Right? So what do I have now? I have x plus equal to 9. Right? This is what I have. So what is x? X is 10. 10 plus equal to 9. So x becomes 19. So x becomes 19. What happens to A? A is equal to 9. So when I print A and x, what do I get? I get 9 and 19. Option C. Right? So here you have to know about the precedence and the associativity. The key here is to understand the associativity of the assignment operator. That's the key here. Okay, I hope this is clear. So let's go to question 13 here. So let's go to question 13 here. Okay. Okay, so this is actually a straightforward question. I remember solving it fairly easily, right? So if you look at this, it says unsigned char A equals to 6, B equals to 10, right? You have a char. Char typically is stored using 1 byte. So you have 6, A equals to 6. What is the binary representation of 6? Binary representation of 6 will be 0, 0, 0, 0, 0, 1, 1, 0, because this is 2 power 0, this is 2 power 1, 2 power 2, and 2 power 3. 2 power 2 is 4 plus 2, 6. Yes, this is 6. Now what about B? B, I almost remember it by heart. 1, 0, 1, 0. 2 power 3 is 8. 2 power 1 is 2. Yes, so B is 10. Now what is it asking? It's asking us A and B. Okay, so what is A and B? This is bitwise operation. This is bitwise AND. So when you do bitwise AND, these 4 are 0, so it will be 0. 0 and 1 is 0. 1 and 0 is 0. 1, 1 is 1. And this is 0. Right? So this is nothing but 2. So because I'm printing it as a decimal or an integer value, so this will result in 2. Okay, what about logical OR? A or B, right? 4 zeros, 4 zeros, everything will become 0. 0, 1 is 1 or, right? 1 or 0 is 1. 1 or 1 is 1 and 0. Okay, so what is this equivalent to? This is 2 power 1, this is 2, this is 4, and this is 8. 8 plus 2, 10 plus 4, 14, right? So this will print 14. What about the next one? A XOR B, right? A XOR B. We discussed about XOR in the course videos, right? If both are same, right? If both are same, we'll get 0. If both are different, we get 1. Since they're same, you get 0, 0, 0, 0. 0, 1, you get 1. 1, 0, you get 1. 1, 1, you get 0. 0, 0, you get 0. So this is what you get. And what is this? 2 power 0, 2 power 1, 2 power 2 is 4, 2 power 3 is 8. So this is 12. Right? So the third statement prints 12. What about the fourth statement? B left shift 1. This is your B. If you left shift it by 1, what happens? 0, 0, 1, 0, 1, 0, 0. This is B left shift 1. Right? So B left shift 1 is equal to this. What is this now? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Right? 2 power 4 is 16. Right? 2 power 2 is 4. So this is equal to 20. So this will print 20. Now B right shift 1. What is B? B is 10. Right? B is 10. So if you right shift it by 1, what happens? 0, 0, 0, 0, 0, 1, 0, 1. So this is 2 power 0, which is 1, 2 power 1, 2 power 2, 4. So sum is 5. So this is what you will get printed as 2, 14, 12, 20, and 5. Okay, so let's see which option is true here. Right? So option B, right? 2, 14, that's the order, right? 2, 14, 12, 25. Yes. B is the right option here. So A, there is this matching that you have to go through, and option B will be the right option that you'll get, right? Straightforward question, nothing very hard in this, nothing very tricky. So my suggestion is, whenever you have a tricky question, again, I'll tell that at the end anyway. So let's look at the 2 more questions that we have here. And then I'll take some general questions also. Since we have some time, I'll also take some general questions. I'll also take some general questions on the live chat. Okay, once we finish these couple of questions. These are easy questions, by the way. So you have k equals to 1, 2, 3, 4, 5. Okay, if you notice this, you have k equals to 1, 2, 3, 4, 5. Right? Parenthesis has the highest precedence. And since I have a bunch of values which are comma separated, the last value will be what is the resultant of this. Right? So this is equivalent to k equals to 5. When I'm printing this, I'll get 5 here. What about here? This is a tricky case because there is no parenthesis here. K equals to 1, 2, 3, 4, 5. Using a mnemonic, this has the higher precedence over comma. So k equals to 1. So k is assigned a value of 1, right? And then you get 1, 2, 3, 4, 5. K equals to 1. And k equals to 1 as an expression returns 1. Right? K equals to 1 as an expression also returns 1. The evaluation of this expression is 1 itself because the RHS is 1. Right? So you have 1, 2, 3, 4, 5, which evaluates to nothing. When you print k, you'll get 1 here. So the first expression, the first code prints 5, the second code prints 1. Okay, so let's actually see this. So the first code prints 5, the second code prints 1. So option D is the right option here, right? So let's go to question 15 now. Okay, today the questions, I mean, some of these questions are easy. If you know precedence, see, many of these questions are based on precedence and associativity, right? That's because those are the 2 topics that some of the previous gate questions also focus on. Again, we'll revisit some more questions when we visit for loops, when we visit functions, etc. Okay, so let's go here. So it says a equals to 1, b equals to 2, c equals to 3. Very good. Now it says c equals to a double equal to b. Okay. So if you remember our mnemonic, right? Pumas, rebel, tack. Right? If you remember this, so this e is the double equal to and the not equal to symbols, right? And assignment is here. Your assignment is here. Again, sometimes you could get confused that this is assignment. No, this is addition. Whatever is there after multiplication is addition. Okay, because there is a here, there is a here. Sometimes people do get confused with this. Okay, just be careful with that. So here, this e is the double equal to and the not equal to. So now, since this has higher precedence, this would get executed. A double equal to b. A equals to 1, b equals to 2. A is not equal to 2. So, or 1 is not equal to 2. Right? So this will evaluate to false. What is false? False is nothing but 0. Right? So c equals to 0 is what this will result in. And c will become equal to 0. So when I print this, I'll get c equals to 0. Right? See, all these are all about associativity, and all these questions are about associativity and precedence. Okay. And I think there will be a couple of questions. There will be about 2 questions, if I'm not wrong, which I have not covered in today's session, in this session, which could be present in your test. Okay, if you're not able to figure that out, again, it's very easy to figure it out. I'll show you a simple example. But anyways, if you have any doubt with that, just shoot us an email. Let me just stop sharing the screen here. Okay, let me just adjust the camera. Give me a sec, folks. I think my camera went crazy. Okay, sorry, my lighting went crazy. I need to adjust the lighting here. Okay, I think my lighting went wrong. Okay, just give me a second. I'll adjust the camera also. Just give me a sec. Okay, so I hope the camera is also all right now. Okay, this looks good. So let me go to the comment section here. Okay, yeah, I'm very happy that yeah. So there are no very good. Mrunmoy is asking, what about ternary operator based questions? We'll ask them. Don't worry. So there are some ternary operator, very interesting questions about ternary operators that we wanted to cover, but many of them from previous gate questions or questions that we were designing have overlaps with for loops and with other concepts. So you will get many more questions about precedence, about ternary operators, bitwise operators, even in the future practice problems. Okay, so don't worry about it. You will encounter many more of these cases. Okay, we'll ensure that you'll get ample practice. So don't worry about that right away. Okay, so good question, Mrudmoy. So it's a good question that we don't have ternary operators here, because when we were designing some of these questions, we thought ternary operators are better suited when we having a bunch of if-else conditions or with for loops and more complex structures. Okay, so thanks a lot. So these are the questions for today. If there's so one other suggestion that I'll make here is if there is any question that sorry, we are not planning to provide a PDF because so somebody's asking this question. I'll come to your question, Sagar. It's a very good question that you asked, and there is a reason why we are not giving a PDF version of the questions. There's a very important reason. I'll tell you what. So before we go there, for any question, if you're not sure, just use one of the online IDEs, right? Your online GDB or IDE one. Write the code, play around with the code. That's how you become more comfortable with it. Okay, so that's what my strong recommendation is. The other thing is about providing this as PDF. The biggest problem here is we want you to get used to taking the test online. Okay, because that's what you would do in Gate, right? That's why even the interface, for even basic practice problems, the interface that we're giving you is very similar to the Gate interface, and that's by design. Okay, we want you to get comfortable with using the online tools. If you need a calculator, we have the calculator, and we want to simulate exactly how you would take the real world test. If I give you a PDF, you'd start solving it on a piece of paper or print it out. The problem with that is you're not simulating how you would take the test. In the real world, when you write the actual Gate exam itself, you should have like the interface. All the tools should feel fully native to you because you've solved a few thousand problems, either through practice sessions, topic-wise tests, or subject-wise tests, mock tests, etc. The whole UI of Gate exam itself should feel very natural. And that's why we are asking everybody to actually take the test in the browser itself using this IDE or using this interface. That's the whole reason. Okay. So sounds good. Oh, I think some of my teammates are also responding here. Thank you, folks. Thank you, team, for joining in. Oh, they've been there for a while. Okay. So good. I'm glad some of them are joining in because I was not sure whether they would join in today because it's a holiday for all of us. So I thought we were even considering postponing this live session, but we thought, okay, anyway, since it's Saturday evening, let's finish it off. And the questions are also fairly straightforward, right? So thank you, team, for joining in on a major vacation or a major holiday or a major festival day. Anyway, so don't worry about referring these questions. You'll have access to all of these questions. Okay. So these questions will be you can access these questions. You can access each of these practice tests, right? You'll have access to all of these practice tests till the time your registration is valid. So don't worry about it. You can come back, retake the test, or if you've made some errors, my suggestion is this, folks. Whatever questions you have incorrectly answered, please make a note of them. Okay. Probably you could note it down on a Google Doc or something. And maybe a week later, okay, come back to that question and see if you can solve it correctly. Or ask yourself, so this is a very nice way of revision because some of you have asked me about how to revise better, right? So all the questions that you have incorrectly answered, just say, okay, practice test so-and-so number. This is the question number that I did not answer correctly. Make a note of that in a Google Doc. Come back to these questions maybe a week or 2 weeks later. Try to answer these questions. Not because you've forgotten the actual answer. Right? In a couple of weeks, you would forget. Now come back and answer the question now very carefully and see if you're getting the answer right. That way, you will know whether. So this is also a form of revision, right? Because you're revising the concept by solving problems, right? So don't worry, you'll have solution videos also. Don't worry about that. So all these are solution videos, right? So for every practice test, right now, since we're anyway doing live sessions here, so we'll have for every practice session, you'll have the answers in video, just like this. So don't worry about that. Okay, sounds good. So tests will be available. You'll have video solutions just like this in lots of detail. You'll also have text solutions. Again, for all of your questions, my team will send out a document or with any question you have. By the way, any question, any point of time, please shoot an email to us and we'll respond back as soon as possible. Or if there is something that requires immediate response from us, give us a call. We'll try to answer as many calls as we can. Okay, sounds good. So somebody is asking a bookmark tool. That's a very good suggestion, Abhishek. Can you just email us and we'll try to incorporate that. So we'll try to keep a bookmarking tool which will tag all the questions that you've incorrectly answered. It's not very hard to incorporate. Please do email us so that we have all of these requests in one place. Right now, the problem is somebody would tell me something. It's very hard to communicate with the other team. If you can shoot an email to us, I think that will be great. Hey, somebody is asking a very good question. Shivam, Is teaching faculty good at IASC? So very good question, actually. Again, whatever institute you are at, whether you're at Stanford, MIT, you name it, teachers come in all shapes and sizes. Okay. I've seen phenomenal researchers who don't teach very well. I've seen phenomenal teachers who don't do great research. And I've seen people who teach well and also do great research. So it's almost impossible to guarantee at any institute, forget about Institute of Science. Okay. For at any institute in the world, it's almost impossible to guarantee that you will get the best teachers. But IASC itself has some very good teachers. Okay. They're both great teachers and phenomenal researchers. I'll give you some examples. I mean, these are people that I remember. We have Professor Sunil Chandran, who teaches graph theory. He has a charm of teaching. I still recall his classes. The way he used to teach us graph theory is, in every class he used to teach us one proof. And the way he used to teach us proof is, he would say, don't read the textbook and come to me. If you come, it's useless to you. And he would take a problem. It's still fun. He takes a problem and he'll work with us to prove together. And if we take him in a wrong direction, he'll go in the wrong direction and show how we get stuck in that proof and come back. Okay, that's a very nice strategy of teaching. Professor Sunil Chandran teaches that way. Then I remember Professor Chiranjeev Bhattacharya, who is my mentor and who was my advisor, who teaches machine learning. Phenomenal guy. Okay, he's full of energy, bubbling with energy. He teaches beautiful math. Phenomenal teacher. I also remember Professor Kavita, who's now at Tata Institute of Fundamental Research. She taught us algorithms, and I took a couple of courses from her, both in algorithms and topics in algorithms, which is a research level course. And she would do so much hard work. We used to see her in the lab almost till 1 a.m. and 2 a.m. She used to work so hard to prepare the best teaching material for us. We used to joke that she works harder than us to teach us, right? And her classes are like phenomenally interesting. She would go step by step, very methodologically, very nice. So again, these are some of the professors that I remember at the top of my head. If you ask me, these are the 3-4 professors that I recall. Of course, there are other great professors at the Institute of Science. Of course, everybody has their strategy. Okay, so there are professors who would go very rigorous mathematical proofs, step by step rigorously. There are others who wouldn't go very rigorously, who would more applied in nature. So people come in all shapes. Okay, and when you're at an institute like IASC, you'll get enough help and mentorship from your seniors, your PhD students, your lab mates, that you can easily pick up these topics. Okay, sounds good. So, hey Saket, thank you for appreciating the blended course. We thought a lot about the blended course because we wanted to have a lot of interaction between the students and the team, and we thought these live sessions twice a week are certainly a great way to keep the motivation levels up. But anything that you want to chat, we thought, because one of the things that we have noticed when we talk to a lot of previous students is they lose motivation or they lose the interest and all of that. So we thought it's very important, unlike typical online courses where there is very little face time with the team, which is teaching and which is mentoring. We thought this is a better model where you constantly have somebody whom you can approach, who can help you stay on track, keep motivated, all of that stuff, right? So we put in a lot of thought process behind the blended course. Thank you very much. So MTech at IASC or Applied AA course, I would say go for MTech at IASC. That's what I would recommend. Okay, even though we run Applied AA course, I would strongly recommend you go and pursue MTech at IASC. There are a couple of reasons for it. Okay, let's be practical about it, right? An IASC, a degree from IASC is very, very valuable in the long run. Okay, a course completion from Applied AA course will certainly get you an AI job, but at the end of the day, it's not a brand value that will stay with you in the long run. It's no way comparable to Indian Institute of Science, which is a 100-year-old institution. Okay, I'm happy to be associated with both these brands, but the brand value that Indian Institute of Science has is terrific. And also, IASC prepares you for research and PhD, okay, which Applied AA course does not. So to be honest, there, Applied AA course helps you transition from non-machine learning roles to machine learning roles, while IASC gives you more foundational stuff. Remember, you're spending 2 years there and doing tons of courses. So your breadth of knowledge, your depth of knowledge will be much more because you're spending much more amount of time. It's a full-time in Institute of Science. There is one more catch there, which is if you can crack, again, the multiple ways of looking at it. Okay, so the other way of looking at it is brands don't matter in the long run. Suppose if I go for an interview today, nobody will ask me whether I studied in Institute of Science or IIT or Stanford. Nobody cares about it. People will ask me about my most recent 2 to 3 years experience. They'll say, okay, you worked at Yahoo. So sorry, you worked at Amazon, you started your own startup. So okay, so that makes sense. Nobody cares about what I did 10 years back, right? So with applied AI course, if you can get into a top-notch product-based company, in the long run, there may be a minuscule difference in terms of your career trajectory as compared to Indian Institute of Science. But if you have a choice, I would recommend you go to Indian Institute of Science and learn some interesting math. Again, it gives you a lot of ample space, and it's a very intellectually stimulating environment. I would suggest you go there. Okay. So I'm not from CS background. Can you give me some suggestions for having a strong logic for programming? Surya, very good question here. See, whether you're from a computer science background or not, when we all started off C programming in our BTech first year, we all had no computer science background, right? So to be good at programming, the only way is to practice tons of programs. There is no shortcut. There are only two ways. You got to be a genius, okay, who can figure out solutions to mathematical problems outright, or you have to practice. Of course, if you are more intelligent than an average person, the practice you need will be less. But if you're an average or below average candidate, you would need more practice. See, in life in general, there are two things, okay, which are constants: your ability and your hard work. Or to put it, your smarts and your hard work, right? These are two things. Somebody who does not work hard but is super smart will get ahead in the short run. But the guy who works hard consistently day in and day out, day in and day out, will win in the long run. Okay, because he's updating himself, he's learning new things. So the only way to become a good programmer is to practice, 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 practice. Okay, so that's my suggestion here. So okay, so I'm just going through these comments here. Oh, so good. So do you teach the Socrates method of teaching? I would love to I would love to follow the Socrates method of teaching, where you start with a question and you go deeper and deeper. The only problem is the amount of time it would take to teach a concept like that is much, much more than a typical GATE course. Remember, when we teach for GATE, there is a constraint of time. If I have, let's say, 2,000 hours to teach, okay, which is like massive, which is like typically a GATE course, when we evaluate it, it will be 400 to 500 hours of 500 hours of video content. And of course, if I follow the Socrates approach, which I would love to follow personally, right, I would take about 2,000 hours to do it. Now, while the Socrates approach will make you a much better software engineer, you'll have to start your GATE preparation in your BTech first year or second year, okay, which most people don't, right? So that's the catch here. I would love to do it, but unfortunately I can't do it because of the real world constraints of GATE. So the next question here is which IIT is best for AI research, and if I want to pursue MTech. So IIT Bombay has some very good faculty for machine learning. IIT Madras also has Professor Ravindran and others who are doing some very interesting work. And IIC, traditionally IIC has been one of the most active places for research in machine learning and AI. So these are 2-3 institutions that come to my mind. I have some friends of mine or some peers of mine who are faculty at some of the IITs. So those places are also good, but if I have to pick the best, I think it will be IIC. I don't know much about faculty at IIT Delhi, Kanpur, and Kharagpur. I know a couple of faculty members at Kharagpur, but I don't know all the faculty members. So please do your research. The best way is to go and look at each of the professors' profiles, look at their research publications, and see what they're working on in the last 5 years. Okay. So again, my choices will be biased by my own experiences, right? So please, because I've not done extensive research on faculty at IIT Kanpur or IIT Kharagpur or IIT Guwahati, IIT Roorkee or IIT Delhi, etc. So my knowledge is going to be limited. I've seen some very good faculty at Indian Institute of Science, IIT Bombay, and IIT Madras or IIT Chennai, right? So these 3 institutions I do know. Other institutions, I would not say there are no good faculty because I don't know them firsthand. Okay. Sounds good. Yeah, so Ayush, that's a valid point about the emails. We're just working on that right away. That's the highest priority stuff. So as I think one of my teammates put in, we'll fix it with highest priority. Some of these small but important bugs, we'll fix them ASAP. We're just sitting on them, right? So what about Mahesh, that's a good point. You're asking about undefined behavior in C, right? So we'll cover it as and when the context arrives. And probably we'll take some examples also, because there are some behaviors which are undefined. I think I made in one of the videos, I don't recall exactly which one. I did say that one of these behaviors is not clearly defined and it is compiler dependent. One compiler might execute it one way, the other might execute it the other way. I forgot exactly which one, but I did call that out. So if there is anything, while we discuss each of these concepts in C, if there is anything that stands out, I'll surely do that. Otherwise, if I miss something, please do let me know. If there is any major concept. But guys, by the way, it's very foolish of myself if I think that I've taught everything and I've taught it perfectly. If there is any error, or more importantly, if there is any important concept that you think we missed out, which is very important for Gate, please do let us know. We'll add it out. Okay. So please, that's very important for us. So the other thing is, what is your opinion about computer science in European universities? Like, there are a bunch of phenomenal European universities. For example, you have INRIA in France, you have Oxford and Cambridge in Britain. You have University College London in Britain, which is also pretty good. And you have these universities in Switzerland. What is it called? I keep forgetting its name. There are these two institutes, ETH Zurich, right? It's called ETH, I think, if I'm not wrong. So it's ETH Zurich. So some of these universities are certainly very, very good. They're world class, because I've had some people who are PhDs from these universities who used to work in my team. And ETH Zurich, Oxford, Cambridge. We had some interns from Cambridge one summer in my team. And so some of these universities are really, really good. So don't worry about them. Also, some of the universities in Germany, right? Like Bonn, etc. So these are very good universities. And there is Max Planck Institute anyway in Germany, which is like a series of institutions which are certainly world class, par none. Okay, par. I mean, they're really, really good. There is INRIA in France. So some of these top universities in Europe are certainly very good. So don't worry about them. And they certainly are very high quality. The best way is to look at the professors and the work that they're doing, the teaching that they're doing, etc. Of course, I would argue that every country literally has at least one or two very good universities. Okay, just like India has IACs and IITs and other good institutions like BITS. These are all good institutions, right? Similarly, I think every country, even if, like Russia has St. Petersburg University, which is terrific, right? So almost every major country has at least one or two good institutions. You just got to pick those. Okay, sounds good. Yeah. So any other question? So we'll also share other questions which you can get. Again, most of these questions have been set by us. We did not, because these questions are not available in past Gate questions, etc. So any question that you have, please do email us. We'll try and answer as many as possible over email, because I can give more detailed explanation over email and stuff like that, right? Okay, sure. So we will start pushing out content. This is a good suggestion, Ram Shankar. We'll take a note of it, and we'll try to push content the night before if we can, right? So I think today, tomorrow, day after, we have if else and if else, all these conditional stuff. So if else, switch, etc. We'll try to push out this content. We'll try to do it the night before, but sometimes the editing work is not done, or some of these small bugs get left out. So we tend to push it the next day itself. We'll try and do it the fastest we can, right? Sounds good. So somebody suggesting about UGC net. I haven't gone through those questions. We'll go through some of the questions from UGC net also. And by the way, the very important thing here is, yes, yeah. So this is a question that Sunidya has told. I told you about the compiler specific stuff, right? I plus I, the example that he has just put here. So that's a very good. I think this is the example that I gave. I think some example like this, I think in one of the videos I mentioned that it is compiler dependent, because it's not clearly defined in the C standard on what should exactly be done. Okay, sounds good. Again, any question you have about any of these concepts in C programming, do shoot out an email. We'll try to answer as many as possible over email. Actually, we'll answer almost everything. Okay, we can give you more detailed explanations also over email. Thank you, folks. Thank you for joining on a Saturday evening. Have a good weekend, get some rest, and we'll try to push out content for the rest of the concepts before the next live session. Thank you. Thank you for joining in. Bye-bye.